Hi there, Mr. Sutton here, bringing you the AB Calculus 514 homework solutions on integration by substitution with indefinite integrals. For this problem, I'm trying to take the antiderivative or indefinite integral of this expression. Now, since I see a function in a function and this function's derivative is this other function, I'm thinking this would be a good candidate for substitution. So I'm going to let my u value on this one be x cubed plus 5. And then taking the derivative, we have du equals 3x squared dx. Dividing by 3x squared, we get dx equals du over 3x squared. Now let me substitute back into the original here. So I'm going to write this as x squared times u to the 6th times du over 3x squared. And these x squareds are going to cancel. That's going to be 1/3 u to the 6th. Using my reverse power rule now, this bumps up to an exponent of 7. Dividing by that, we have 1 over 21 u to the 7th plus c. And then substituting back in for u, because all the answer choices are in terms of x, we've got 1 over 21 times x cubed plus 5 quantity to the 7th plus c. So that's going to give us answer choice E. For this problem, I'm trying to get the indefinite integral of this mess. So the key on this one is noticing that we have an inner function down here, 3x squared plus 5, whose derivative, x, is also in the same integrand. So for that reason, we're going to try using some substitution. I'm going to let u equal 3x squared plus 5. And then taking the derivative of both sides, we've got du equals 6x dx. Dividing by 6x, we get du over 6x equivalent to dx. And now we're going to do some substituting in the original. So this is going to be the integral of x dx over, now we're going to have the square root of just u times du over 6x. These x's are going to cancel. So this is just going to be 1 over 6 times, I'm going to rewrite this with a fractional exponent, u to the negative 1/2. And now using my reverse power rule, this bumps up to a positive 1/2. And multiplying by the reciprocal of that, which is 2, I end up with 2 over 6, which is 1/3, u to the 1/2, plus c. And now plugging in for the u here, 3x squared plus 5 to the 1/2, and then we have a 1/3 outside, still have the plus c. So we've got all this stuff, and this is going to give us answer choice, let's see, where's the 1/3? D, there we go. On this problem, we're trying to take the antiderivative of tan of 2x, and this one is almost so simple it's hard, because, I mean, what do we do with tan? Tan is the antiderivative of secant squared, but what's the antiderivative of tan? So the key to getting out of this predicament is to rewrite tan as sine of 2x over cosine of 2x, because if we write it that way, we can turn this into a substitution problem. These are both the derivative of the other. So you can use a little u substitution with one of these to get rid of the other one. I'm going to choose the function downstairs here, cosine of 2x, and I'm going to let that be my u value. And the reason I'm doing that is when I take the derivative of whatever this is, it's going to end up in the denominator the way this usually works. So that way I'll be able to cancel out sine. If I let sine be u, then I'm going to end up with a cosine in the denominator, which is not going to cancel out this cosine. So this is really the only way this is going to work. So taking the derivative of both sides, I've got du equals, and using my chain rule, negative 2 sine of 2x. Then dividing both sides by negative 2 sine of 2x, we get dx equals du over that stuff. Now let's go back and use some substitution. So I'm going to write this as sine of 2x over u times du over negative 2 sine of 2x. And now the sine of 2x's are going to cancel out completely. We've got a negative 1/2 hanging around, and we also have a 1 over u or a u to the negative 1 power, however you want to write that. Doesn't really matter. Now the antiderivative of 1 over u, that's actually ln of absolute value of u, and we still have this negative 1/2 there, and we have a plus c, of course. But now all the answer choices have x's in them, so we're going to have to replace u with cosine of 2x again. So when the dust settles, then this is negative 1/2 ln absolute value of cosine of 2x plus c, which is going to give us answer choice B, right there. For this problem, I'm trying to find the indefinite integral of e to the x over radical x. So since I have an inner function, and it looks like the derivative of radical x might interact in some way with this other radical x, I'm going to try substitution here. I'm going to let my u value be radical x. Taking the derivative of that, since this is really x to the 1/2, I can write du equals 1/2 x to the negative 1/2 dx. And then getting dx by itself, we're going to multiply both sides by 2. And since I really have 1 over radical x, I'm going to multiply radical x over to the other side as well. So that's going to be 2 radical x du equaling dx. Now it's time to do some substitution. So I'm going to replace this radical x up here in the exponent with u. I'm going to leave this one alone because that's going to get canceled out on its own anyway by this radical x. So substituting in, I've got e to the u over radical x times 2 radical x du. And then the radical x's cancel, just as I foretold. So we end up with 2e to the u du. And now taking the antiderivative of that, that's going to be 2e to the u with plus c. And then we're just going to replace that u with the radical x to make it look like one of the answer choices, which is going to give us answer choice A. For this problem, they're asking for an antiderivative of f of x equals e to the x plus e to the x. So this is kind of weird, but we're basically asking for the indefinite integral of this. So we see an inner function and another function that's kind of sort of the derivative of that function, but not quite. The key on this one is you actually had to split things up in the beginning. Since I have addition in the exponent, I can rewrite this as e to the x times e to the x. Because if I were to multiply these together, I would just be adding the exponents and getting what I started with here. So if I rewrite it like this, then I can do the problem a little bit more easily, no pun intended. So I'm going to try some substitution now. I'm going to let u equal e to the x because the derivative of e to the x is e to the x, so some canceling is going to happen here. So if u equals e to the x, then du equals e to the x dx, which means dx equals du over e to the x. Substituting back in, I'm going to rewrite this as e to the x times e to the u times du over e to the x. And then these e to the x's are going to cancel, so I've just got e to the u du now. And that's a very easy antiderivative. That's just e to the u plus c. Substituting e to the x back in for u, I've got e to the x plus c, which is kind of weird to look at, but is answer choice, the closest one here is answer choice E. For this problem, I'm trying to take the antiderivative of e to the x over 1 plus e to the x. Now, since I see a function and its derivative in the same problem, I'm going to try substitution on this one. Let me try a u value of 1 plus e to the x. Now, the derivative of that, du, is going to be just e to the x dx, which means I can rewrite dx as du over e to the x. Plugging all that back in, we can write this as e to the x over u times du over e to the x. These e to the x's cancel nicely, and then the antiderivative of du over u is just going to be ln of the absolute value of u plus c. And since that doesn't match any of the answer choices, let me substitute back for u. So that's going to be 1 plus e to the x inside that absolute value, which is going to give us answer choice B. And if you're wondering where the absolute value went, well, e to the x is always positive. You're adding 1, so this thing can't come out negative anyway. For this problem, we're asking for the average value of f of x equals this function here on the interval from 0 to 2. So for average value, we're going to have essentially 1 over 2 minus 0 times the integral from 0 to 2 of this function. That means we're going to have to take an antiderivative of this function since this is a no calculator problem. So let's start by just getting the indefinite integral of this before we even launch into any of that average value stuff. So to get the indefinite integral, I notice that I have an inner function here whose derivative is some other function. So I'm going to try substitution. I'm going to let u equal x cubed plus 1. And then du is going to be 3x squared dx. So isolating dx, we have du over 3x squared. Great. So now I'm going to have an integral with this, and I'm going to do some substitutions. I'm going to write this as the integral of x squared times the square root of u times du over 3x squared. And these x squareds are going to cancel. I'm just going to have 1/3 u to the 1/2 if I write that with an exponent. Using my reverse power rule, this bumps up to 3/2. If I multiply by the reciprocal of that, 2/3, then that's going to be 2/9 u to the 3/2 plus c. And then plugging my x back in so I can actually use this, I'm going to have, let's see here, this is x cubed plus 1 getting plugged in there. All right, so this is now what we're going to use when we do our average value setup. So I'm going to have 1/2 times essentially this thing being evaluated from 0 to 2. So 1/2 times this thing with 2 plugged in. Here's the general setup. So 1/2 times this thing with 2 plugged in. And by the way, before I even do any of this, I'm going to do 2/9 times 1/2 to get 1/9 out here, so I have less fractions. But now let me plug 2 into my square root here with the cube and all the other crazy stuff going on. So I've got, let's see here, the square root of 2 cubed plus 1, all of it cubed. There's a lot going on there. Minus all of this stuff with 0 plugged in. And if I crunch these numbers, what do I have? Well, this is going to be the square root of 9, which is 3. But I'm cubing that, so that gives me 27. Over here, this is just going to be 1 when all the dust settles. So I've got 27 minus 1 inside this big bracket. Multiplying by the 1/9 out here, that's going to be 26 over 9, which is going to match answer choice A.